Okay, so today I'm going to be covering a lesson on box plots. And box plots is one of those things that at first originally they're hard to understand, but once you get an idea of kind of what's going on, it's a lot easier to, do various different problems on it. So I'm gonna get started by doing a class survey, and I'm gonna ask the kids for numbers between 1 and 30. Okay, and this is just random. I don't know what numbers you're gonna pick, but I'm gonna collect at least 9 numbers. Okay, 9 different digits, either 1 digit or 2 digits, and I'm gonna see the data that I collect, and I'm gonna write it down. Using that data, I'm gonna create a box plot. Okay, and then I'm gonna explain it to you. So let's start. Give me one number between 1 and 30. Just any number.
23.
27.
23, 27,
16.
30.
30,
13.
13,
16.
4.
15,
11.
4, 11,
19.
1, 2, 3, 4, 5, 6, 7, 19, one more.
16.
10.
16.
Let's go with
10.
25. 29.
16. 16.
13.
1.
29.
Oh, okay.
Alright,
Oh, wait,
so
13.
using those numbers, I'm going to create a box plot, okay? But the first thing you want to do, especially when they give you a list of numbers, ladies and gentlemen, you want to organize them from least to greatest. Now, you can also do greatest to least, but what I found is that least to greatest, it just tends to be a lot easier when they're asking you for what's the lowest number or what's the greatest number. I don't know. So to me, it's just a lot easier, but the important part is for you to organize them. So in this case, I'm going to organize them from least to greatest. So the first one that would go is 1,
1.
and then
4.
11,
Four.
no, first 4,
Oh, 4.
then 11,
13.
13,
15.
15,
19.
19,
23.
23,
27.
27, 30, that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's your 9 digits. Okay, now using these digits, I'm going to create a box plot. Okay, so the first thing that they use is called the lowest number. Okay, the lowest number in this case is going to represent 1. Okay, now what they like to do is they'll make a number line looking thing, and they'll usually stop it where the greatest number stops. If not, they'll keep going, but the box is within that. Okay, so now I need to separate my number line. Okay, and most box plots will already give you a number line, but in this case, I'm gonna count by 5. So let's see, 5, 10, 15, 20, 25. Okay, we'll make this 30, 35, and we'll just make this 40. Okay? Now, I know that my smallest digit is 1 or 0 if you want to start this at 0 and that at 1. Okay? And I know that my largest digit is 30. So I know my data is going to spread between 1 and 30. Okay? Then I need to find the median between these two. And here's where this comes in. Okay, the median number is the middle digit between the rest of the digits. So that middle digit, or either single digit or 2-digit, where the rest of the data falls, is my median. Okay, the median of my data. So in this case, I'm going to do an very old school trick. Okay, very easy trick. Okay, to find the median. So this is what they taught me. They taught me to cover the first and last, then the next, then the next, then the next, and it shows my median. In this case, if you saw, my median was 15. Okay, so my median is right here. Okay, now that's that first median. My my data spreads from 1 to 30, but that middle digit is 15. Now here's where the box plot gets confusing, where a lot of people, they're like, well, they don't understand it because a lot of them have never seen it before. So what the first quartile or the lower quartile is the first median between the median. And this, again, that's confusing. Let me explain. The median between the median. In this case, if I start here and I go inside, this is my first lower quartile. And again, the word quartile comes from the word quarter. Quarter comes from the word 4. So I'm dividing this by 4. So 4 sections, okay? So keep that in mind. Lower quartile is that first quartile, and in this case, that number is 11. So my data, that first quarter of my data starts right there. Okay? Now again, I'm gonna do the upper quartile using the same idea, but now I'm gonna do the median, and the end, I'm gonna find that median. Okay? So it'll be from here to here. Okay? And then I go inside, and I find out that it's 23. Now, 23 happens to land more or less like right there, if you can see it. So now what I did is I separated my data into 4 sections. Here is the first section, and it spreads from here to there, all the way to there. They call this the box and whiskers. Okay, this being the whiskers, representing that first section where the data spreads, and the second whisker where the data ends. Okay, here is my first quartile. Here is my second quartile. Here's my third quartile. And again, the word quartile means fourth. Obviously, the median is my second quartile, where the data spreads in half, or it cuts in half. Okay? Here is the concentration of data. So if you notice, all of my numbers fall within 11 and 23, more or less. You can see that the box is concentrated there. These numbers, especially, I'm sorry, in this one I should have ended it there. That was my mistake. Because the data doesn't spread out. The data doesn't spread all the way to 40. The data spreads only to 30. Okay? So that was my mistake. Again, I corrected it. But you can still see the concentration of data. Had I given the kids a choice to give me a number from 1 to 1,000, you would have noticed that the data would have spread all the way around. Okay? These are known. Any number, let's say they would have given me a number here, right? And then I would have said, all right, somebody, just one chance, give me a number that's above 500. And they would have given me 900. The data would have spread all the way over there, but the concentration of the data, where the majority of the numbers are, would have still stayed here. This whisker would have kept going all the way over there, but the concentration of it would have still been here. That is what the box plot, or box and whiskers, comes into play. It shows you where the concentration of the data is. Okay? But these whiskers shows you where the outlier would be. The outlier being the number that is outside, way outside of the concentration of the data. Okay? In that case that I just gave you an example of 900 or 1,000, if the little whisker goes all the way outside. Does that make sense? Now, going back to the terminology, this being the first quarter, the first section where it gets cut into 4s, okay? Second quarter, or what you know as a median, or third quarter, what they also refer to as the upper quartile. Quartile, again, referring to it being divided by 4. Now, I hope this video helps in understanding how to create a box and whiskers, or how to decipher a box and whiskers, how to read it. Okay, I'm gonna try to do a little bit more videos on this. We're not gonna go too far into box and whiskers, but I do want you to have an idea on how to read it. Okay, again, if something doesn't make sense, if something is confusing, please email me and I'll upload another video explaining how to solve these. I think this was a pretty good example, you know, random survey, and I didn't know what numbers the kids were gonna pick, but you know, I did give them only a certain range being the numbers they could choose from, right? And the concentration of the numbers they were giving me was right here. Okay, so I hope that video helps again. Email me, let me know.